Hi everyone and welcome back to Educator.com. I'm Dan Fullerton and today we're going to continue our mini lessons as we do the first page of the A+ Physics worksheet on Newton's third law. So take a minute, download that from the link below, see if you can do it, and then let's check our answers together. All right, number one. A student pulls a 60 Newton sled with a force having a magnitude of 20 newtons. What is the magnitude of the force that the sled exerts on the student? Well, if the student pulls with the force of 20 newtons, then the sled must exert that force back on the student by Newton's third law. The 60 Newton sled is just referring to the weight of the sled. So this one's all about reading the question. Number two, if we have a 65 kilogram astronaut and the astronaut exerts a force with the magnitude of 50 newtons on a satellite that she is repairing, the magnitude of the force that the satellite exerts on her is, well, it's got to be the exact same. Newton's third law. The force of object 1 on 2 is equal in magnitude and opposite in direction to the force of 2 on 1. Number three, a 400 Newton girl, so that's the weight of the girl, standing on a dock exerts a force of 100 newtons, so the girl is exerting a force of 100 newtons on a 10,000 Newton sailboat. That's the weight of the sailboat as she pushes it away from the dock. How much force does the sailboat exert on the girl? Well, that's going to be equal and opposite to the force that the girl exerts on the sailboat. That is 100 newtons, so this also must be 100 newtons. Don't let the weight of the girl or the weight of the sailboat throw you off. It's all about reading these questions carefully. Number four, a carpenter hits a nail with a hammer. Compared to the magnitude of the force the hammer exerts on the nail, the magnitude of the force the nail exerts on the hammer during contact is, well, it must be the exact same. Again, Newton's third law, forces come in pairs, same magnitude, opposite in direction. Number five, a woman is pushing a baby stroller. Compared to the magnitude of the force exerted on the stroller by the woman, the magnitude of the force exerted on the woman by the stroller is, well, again, exact same thing. Hopefully we're catching a pattern here. The same, Newton's third law. Number six, when a child squeezes the nozzle of a garden hose, water shoots out of the hose toward the east. So if water is shooting out toward the east, what is the direction of the force being exerted on the child by the nozzle? Well, again, Newton's third law, if the water is shooting out toward the east, the force must be to the opposite side or the west. All right, last question. A 100-kilogram boy and a 50-kilogram girl, each holding a spring scale, pull against each other as shown right here. The graph below shows the relationship between the magnitude of the force that the boy applies on his spring scale in time. If you notice, it goes from 0 to about 12 newtons linearly over 3 seconds. And the question we're being asked now is which graph best represents the relationship between the magnitude of the force that the girl applies on her spring scale in time? Well, again, they have to be the exact same but opposite in direction by Newton's third law. The graph that goes from 0 to 12 newtons linearly is this one, number 1. All right, that concludes page 1 of the Newton's third law worksheet. Thanks so much for your time, everyone, and make it a great day.